Two professors from Purdue University reported that for a typical small-sized fertilizer plant in Indiana, the fixed costs were $235,487 and it costs $206.68 to produce each ton of fertilizer. A. If the company planned to sell the fertilizer at $266.67 per ton, find the cost C and the revenue R equations for X tons of fertilizer. Okay, let's start by analyzing the cost. There were fixed costs, and then it cost $206.68 to produce each ton. So the cost is increasing at a constant rate. That means that we can express the cost as a linear function. So we'll write the cost C is equal to the fixed cost, $235,487, plus the variable cost, $206.68, multiplied by the number of tons, which is given to us by the variable X. To write the revenue equation, we observe that the company is planning to sell the fertilizer at $266.67 per ton. So the revenue equation will simply be 266.67 multiplied by the number of tons sold, which is X. Part B says graph the cost and revenue equations on the same graph and calculate and interpret the break-even point. Well, C and R are both linear equations, so both will graph as straight lines. In order to start, we might make a table of values to get an idea of where the break-even point is so that we can decide what scale is appropriate. So let's use our calculator to do that. Turn your calculator on, go to y equals, enter the cost equation for y1, so that will be 235,487 plus 206.68 times X. And for y2, enter the revenue equation, 266.67 times X. Now the break-even point, that's where the cost and revenue are both equal to each other. So let's just investigate and see what happens as the number of tons increases. So we'll go to table set, which is second window, and we'll start off with table start 0. That will give us our initial cost and our initial revenue, and we'll start by incrementing by 1 ton at a time. Make sure that the independent and dependent variables are both on auto. So to go to the table, we hit second and then graph. And we can see in the first row that our initial cost is $235,487, and since we haven't sold any fertilizer yet, the revenue is 0. After that, we can see that our cost is increasing. The revenue is also increasing, but the revenue is increasing at a slower rate. We want to find out when the two are the same. Now we can see right away that the revenue is not catching up to the cost very quickly, so it might be wise to choose a larger increment for our X. So let's go back to table set, second window, and instead of using an increment of 1, let's say we use an increment of 100. And then go back to the table, second graph. Okay, we can see that the cost is increasing, the revenue's increasing. When we look at the bottom row, these two numbers still are not very close together. So let's use an even larger increment. Let's go back to table set, second window, and change the table increment to 1000 instead. And then go back to the table. We can see once again the cost is increasing, the revenue is increasing. Now we see a little bit of a strange notation here, this E6. That scientific notation, that means times 10 to the 6. So 10 to the 6th is 1 million. So we have 1 million for the cost, 1 million for the revenue when X is around 4,000. So we can see that the break-even point is somewhere around 4,000. Prior to that, the cost is more than the revenue, and after that, the revenue is more than the cost. The break-even point occurs somewhere around 4,000. In order to sketch a graph of this on our calculator, we can use the table to create a good viewing window. So notice that since our break-even point's around 4,000, we might want that to be in the middle. So maybe we could go from 0 to 8,000 along the x-axis, and our break-even point or our cost and revenue are both around 1 million. So again, if we want 1 million to be in the middle, then we might go from 0 to 2 million along our y-axis. So let's go back to the window, and we'll make our x minimum range from 0 to 8,000. We'll use a scale of 1,000. For the y values, we'll start off with a y minimum of 0 and a y maximum of 2 million. And for the x scale, I'm going to use 1/10 of 2 million, which is 200,000. And then we'll go to the graph. Okay, we can see that both the cost and revenue are increasing. The cost initially was more than the revenue, so our cost equation is this line here, and our revenue started off at 0 and increased faster than the cost, and we can see that our break-even point is at this point of intersection. So to find the point of intersection, we can go to Calculate, Second Trace, select option number 5 for Intersect, and then just press Enter to select Y1, Enter to select Y2, and our cursor is already fairly close to the point of intersection, so we press Enter one more time, and we locate the point of intersection. It's at approximately $3,925.44, and the revenue and cost are both $1,046,796 at that particular point. Okay, so let's go back and complete the exercise. Okay, for part B, we're asked to graph the cost and revenue equations on the same graph. So draw a set of axes, make a t-axis, scale it from 0 to 8,000 with a scale of 1,000, and then we need a cost and revenue axis. So we're going from 0 to 2 million with a scale of 200,000, just like we had on our calculator. And to graph the cost equation, we locate a couple of points on the graph. Our initial cost was 235,000, so that would be a little bit more than 200,000. And we've determined that our break-even point is 3,925, which is just a little bit more than 4,000, and 1,047,000, which is a little bit more than a million. So we can plot our break-even point, and then we need to draw a line passing through that break-even point. Okay, next we want to graph the revenue equation. We know that the revenue started off at 0, so we can start at the point 0, 0, and we want that to go through the break-even point. So we've just graphed our cost and revenue equations on the same graph. And we've calculated the break-even point, so let's go ahead and label that. Our break-even point is approximately 3,925.4, and the cost and revenue are both about 1,046,000. And I'm just going to round 796 off to $800. Okay, so how do we interpret this break-even point? Well, it tells us that if the company sells 3,925.4 tons of fertilizer, then it will break even, because both the cost and the revenue will be $1,046,800 at that particular point. The last thing that we're asked to do in Part C is to indicate the region where the company would make a profit. Profit occurs when revenue is greater than cost. So what we want to do is to shade in the region on the graph where revenue is greater than cost. Well, revenue is in blue, cost is in red, so on the graph that will occur when the blue graph is above the red graph, and that occurs in this region right here. So this will be the profit region.